Hey there, TouchDesigner developers. Jack Delora here with the Interactive and Immersive HQ. In this video, we're going to continue our artist recreation series by recreating the work of Adam Ferriss, specifically this cool effect called the churning hue cycle in TouchDesigner. So this is a really interesting feedback-based effect built with GLSL that basically rotates the texture coordinates over time based on their hue and gives us this super interesting and cool effect. So we're going to look at adapting the GLSL code for use in TouchDesigner and then add in some additional tweaks of our own. So before we get started, I wanted to give you a little bit of a background on Adam Ferriss. Adam Ferriss is one of a number of people that actually inspired me to kind of follow this path and got me really interested in generative art in the early 2010s. Around that time, Adam and a number of others were experimenting with tools like processing and open frameworks to create experimental visual art pieces. Adam got well known for a number of works, both static images and GIFs, along with web-based works, but that kind of focused on pixel sorting techniques. And the series here, 500 Years Away, is one specifically that I remember seeing quite a lot about at the time. So these are built with processing and open frameworks, and again, have this kind of glitchy aesthetic created using pixel sorting. So these are some super cool stuff that he was working on at the time. But as I mentioned, he was also working in a browser-based fashion as well. And Seeds from 2014 is another piece that I particularly remember, a drawing tool controlled by cellular automata. And this is, again, web-based. It still works and creates these beautiful colored squares and allows you to draw and sort of create these little visual experiments in your browser. So all of these works were very inspiring for myself and many others at the time. And along those same lines, Adam also started experimenting with shaders. So Shadertoy, if you're not familiar, is a platform that has been around for a long time now that allows people to share kind of experimental shader programs and then enable you also to kind of look at their code and run them within the browser. So Adam, fortunately for us, posted a number of different shaders to Shadertoy over the course of a couple years. And today we're specifically going to look at the churning hue cycle effect that he posted back in 2016. And we're going to work to adapt this to TouchDesigner so we can kind of use it with the tools maybe that we're more familiar with and experiment with it from there. So before we take it over to TouchDesigner, I just thought I would point out again, Adam Ferriss's website, amf.fyi, if you're interested in diving into any of his other works. Definitely worth a check to get some sort of inspiration for your own practice. And I will post the link to the Shadertoy example that we're going to be using so that you can open this up in your browser as well. So I've got TouchDesigner up in the background, but I wanted to first walk you through the kind of architecture of this Shadertoy example, because it'll help us to set up our little GLSL network. So first of all, we've got our code here in this tab called Buffer A. And this is going to be all the code that we will adapt for use in TouchDesigner with the GLSL top. At the bottom, we've got a number of inputs. And starting here on the left, we have what is called a buffer. In TouchDesigner terms, this will be a feedback top. And then we've got a texture coming in on the second input here, which is an image found on the textures page. So we can just provide any image that we like for the second input. And then for the third input here, we have a noise texture, which is used to provide some randomness to this effect within the code structure. So we're going to need basically three inputs for our particular network in TouchDesigner today. A feedback into the first input, a texture of choice in the second input, and some noise into the third input. Now that we've got that squared away, we'll set up the basic network first, and then we'll come back and grab the code and start adapting that to work in TouchDesigner. So I'm just going to move this right out of the way, and I've got a blank network here. I'll start off by adding in a GLSL top. So this is going to be, again, where all of the code resides within this GLSL1_pixel dat. This is our pixel shader, and that, again, is where all the Shadertoy code will go. Now, fortunately for this example, we actually do have 3 inputs on the GLSL top itself. If we ever needed more than 3 inputs, there's also the GLSL multi top, which has a multi input instead of single inputs. So with that aside, let's go ahead and add a movie file in top, which we'll use to load a texture. And what I did at the beginning was to use the jelly beans image here. So I'm just going to use that again. Now, one of the situations that we may run into with our effect today is that we may provide images that are a different resolution than this jelly beans image, which is 1280 by 720. And so I like to add a fit top after my kind of input texture, so that if, I have something that is a different scale, I can easily kind of fit it to the resolution that we're going to be working with. And today that resolution is going to be 1280 by 720, so that anyone with the non-commercial license can follow along. So I'm going to go ahead and set the resolution here to 1280 by 720 in the fit top itself. If we were to, again, come across a texture that is a different scale, we could come back and manipulate this fit parameter as needed. So we've now got our input texture. And so what I will do is to add a feedback top to it. Again, the feedback top is what will be connected to this very first input 0. And so I can go ahead and make that connection now. And then we're going to want to connect this fit top directly to the second input. That, again, is providing the direct texture itself. So what I'll do is I'm just going to add a null. And this will be called null input. And we'll connect the fit to that and that to the second input. And then finally, we're going to need some noise. So I'm going to add a noise top, and then I will connect the output of the fit to the first input here. That's going to set the resolution for us. And I will then come to the output page and change the RGB mode here to noise, so that we're just outputting noise and not compositing the input with the noise. We can then kind of adjust this to taste. The original effect had a RGB noise that had what looked like a very small period. It looks almost like snow on a analog TV. So we'll set this to something like maybe 0.1, or actually maybe even lower than that. How about 0.01? And get something that looks like that. And we'll connect that to the third input. Finally, I'm going to add a null to the end. And this will be the kind of end point of our effect. So the last thing I'm going to do before we dive into the coding portion of this is to actually set a target top in the feedback top. And I'm going to do that by dragging the GLSL top onto the target top parameter. That has now started generating feedback, and we can move on to our code. So we'll bring up the Shadertoy window again. And what I'm going to do here is to just select everything in this buffer A, and we'll go ahead and copy that. Again, we're going to have to make some adjustments here. So we're going to paste this into our GLSL1 pixel dat, and then kind of really rework it so that it works with the formatting that TouchDesigner requires. So now that I'm back in TouchDesigner, I'm going to open this with an external code editor by hitting Control E, and I'll bring that window over here. Now I want the general formatting that has been laid out for me here to stay the same, because what's going to come from Shadertoy for this main function is going to be a little bit different. And so I'm going to reuse this component. But I think what I'll do to start is to paste everything above this example pixel shader line. So there's all of our code. I'll make this a little bit bigger. And what I can see from the top is that I have a constant that's defined. Then we have a couple of functions which are used to convert RGB pixel values to HSV, and then take those HSV values and convert them back to RGB. Then we have our main function, which again, in Shadertoy terminology looks a little bit different. We're not using exactly the same thing as TouchDesigner is going to need. And eventually at the bottom here, after doing some texture sampling and manipulating of some UVs, we are setting our final output with the frag color equals statements at the bottom. So the first thing that I'm going to do is to have a look at my code here and note the areas that I'm going to need to change. So Shadertoy has a number of standard variables that we will not be able to use directly in TouchDesigner without defining them. So there are things in Shadertoy like this eye resolution, for example, that is just something that's kind of by default passed into the shader. It gives you the resolution of the output. Again, we can pass in those values ourselves, but we're going to have to do that in order for this to function. Likewise, Shadertoy uses this eye channel terminology for the inputs to the shader. And if we scroll down to the bottom, you can see that we have an std2d inputs expression for accessing the inputs in TouchDesigner instead. So all of these eye channel references are also going to have to change. Another thing that Shadertoy has is this eye time variable, which is, or I should say uniform rather. And this is a timer that will just count up indefinitely and is useful for all kinds of effects that need to change over time. Again, we don't have that in TouchDesigner by default, so we're going to have to set up a uniform for that. And then let me see if we've got anything else that we're going to need to pass into this. Down here, this little section of code here allows us to reset the effect, kind of giving the effect that you saw at the beginning where we see the original image and then it is sort of manipulated by the shader. We're going to actually remove this portion of code that relies on this iframe variable or the mouse click and just replace it with a uniform that we will control with the keyboard. So those are all the places to start that we are going to make some changes to. And we'll come back to the top and make our way through the code. So Adam has this AMT, which I'm assuming is for amount, this constant at the top. It's actually not used anywhere within this code, so I'm just going to remove that. So now let's go ahead and set up some uniforms. I'm going to start off with a uniform vec2, which is going to be called res, and this is going to be a uniform that will be used to provide the resolution to a number of places in the code where it is utilized. And we're going to pass that into the shader code instead because it has the potentiality of changing depending on what you input into this network. So I'm going to use the res terminology because that is what's used elsewhere in the code. And once I do that, I'm going to delete this line number 23, where it's being defined in the main function as it will no longer need to be defined there because we're passing it in. Next up, we're going to add a uniform float, which will be called reset. This will allow us to use our keyboard via a keyboard in chop to reset the effect back to its initialized state. So I've got those two at the top, and I think that's everything. Oh, we're also going to want to define eye time as well. So this, again, will be a float. uniform float iTime. And if you want, you can make these alphabetical just to keep things organized. So I've got my vec2 at the top and then my floats. That's looking good so far. iTime again is going to be used within this function to add movement. So we're going to need that. And with that, we are done defining our uniforms. I'm just going to save. We're going to leave the RGB to HSV and HSV to RGB functions alone, and we'll come down to our main function. Now, I mentioned that the way that this is declared is different coming from Shadertoy than it will be in TouchDesigner. So I'm going to go to the bottom here, and grab both the out statement and then the beginning of this void main function at the bottom. I'll copy that, and then I'll scroll back up to line 23, where I'll replace, starting with this curly brace, the void main function declaration. So we've got our out here set up for the frag color. Then we've got our void main function, opening curly brace, and now our function falls within that section. So the next thing I'll do is come to line 26. We've got this vec2 UV, which is set equal to this frag coord over resolution. We actually have a handy shortcut in TouchDesigner where this is calculated for us. We don't need to be calculating this and utilizing these different variables. So what I'm going to do here is to replace this with vuv.st. So that's lowercase v, capital U, capital V .st. Following that, we've got a number of lines which do some manipulation to this UV value. And then we move on to some texture sampling. Now, I mentioned here, we've got some iChannel inputs, which we're going to have to change. So I'm going to come again to the bottom where I've got this std2d inputs and then brackets 0. I'm going to copy this portion only of this commented out statement. And then I'll come back here and remember that this is iChannel 2 that I'm replacing. So I'll paste over iChannel 2 and I'll put the number within brackets here to be 2 as well. So we are, again, sampling from the third input in that case. For iChannel 0, we'll just paste over that, std2d inputs 0. Again, we'll do the same thing in this call out vec4 as well. We want input 0. And then from there, we are good. Everything else is okay. Now, down here in this if statement, if iframe is less than 10 or imas.z is greater than 0, we're going to replace this with if reset is greater than 0, then we're going to want to sample from the first input, or rather the second input, index 1. So again, I'm going to paste over, delete this iChannel 1 reference, std2d inputs 1, comma UV. And if we look at our final output here, we can see that the way that we normally do things in TouchDesigner is to use this td output swizzle function. So what I actually might do here is, rather than set this texture function directly equaling frag color, or rather setting frag color to equal this texture function, I'll put this in a vec4 called init, and then I will set frag color equal to td output swizzle init, just again to kind of follow the methodology. And then likewise, I'm going to, instead of sending this call out variable straight, or rather setting frag color equal to call out, I will again wrap this in the td output swizzle function. So with all of that done, I should now be able to delete this little example code at the bottom, save, and this should run correctly. Now, what I'll do here is to paste this in the description, or I'll leave a link so that you can access the final version of this code yourself. And I'll also see if I can zoom out a bit so that you can pause the video here. The main thing, again, is this main function to replace all of the different inputs with the corresponding TouchDesigner kind of terminology, std2d inputs. And now that we've had a moment to look at this portion of the code, let's scroll back up to the top where I've defined 3 uniforms and also manipulated or changed the way that the void main function is declared. Okay, so hopefully you've had a chance now to look over the code yourself, and we'll go ahead and save that and head back to TouchDesigner and see if we have any errors. So we have a successful compilation, which is great. We have a little caution flag on the GLSL top itself, which is telling us that all those uniforms that I defined in the code have not been assigned yet. And that means that we need to head to the vectors page and add them into our vector list. So what I'll do from the top is to add in first resolution, or actually, excuse me, that should be res for the resolution of the input. And then we will add in next our iTime variable, and then our uniform rather. And then finally, we're going to add in reset. Once we add all of those things, you'll see that we now have our output image is jelly beans and no longer that transparent texture. We don't have the caution flag anymore. But because we haven't yet assigned anything to these values, or at least values that will make this do anything, you can see that we're just getting a static image. And so what we need to do from the top is to first set our resolution values. So we could do this a number of ways. I know that the output, because I'm using this fit top, I know that my output here will be corresponding to whatever the resolution we've set in the fit top is. And so what I can do is to make a chop reference from the common page of the fit top to those res values. So that is what I will do. So I'm going to go ahead and click the little drop down here. I'll drag first off of the resolution W parameter, go back to my GLSL top, and I'll keep holding that left mouse button down until I get to value. And I want the first value here for the X, or the width coordinate, and I want to make a reference. And you'll see here, here's the expression that we could have just typed in instead. Now for the height, I'm going to just copy this expression and paste it, except that I will replace the W at the end to resolution H. So op fit1.par.resolution H to get us the height of that particular fit top. Next up, we've got iTime. And iTime, again, is just a time value that is intended to just count up indefinitely. And for this, we can use our handy abs time.seconds reference. So I'll go ahead and click the drop down here. And for this vec1 value X, I'm going to type in abs time.seconds, and we'll multiply that by 0.1 for good measure and hit enter. Now we've got 2 of our vectors assigned. The last thing I'm going to do here is to set up a reset value. Right now, the reset is greater than 0. So that is why we're being held in this sort of reset state, this initialized state where all we see is the texture coming in the second input. But what we can do is to add in a keyboard in chop. And if I want to just be able to sort of pulse that whenever I press the key down, I can just leave it as is, and I'll make a chop reference from this keyboard in chop over to the value, again, the first value parameter there. So again, that's vec2 value X, and I want the chop reference made there. You'll notice as soon as I've done that, we have successfully generated the effect. So I can hit the 1 key on the keyboard and reset this and have it start generating the feedback again from that initial jelly beans image. But for all intents and purposes, this looks pretty much identical to the original on Shadertoy that Adam Ferriss created back in 2016. And, we were able to do it obviously with a little bit of a lift in GLSL, but all in all, not that complex of a network. Next up, we're going to have a look at a couple of things that we can tweak to modify the output of this effect. The first place that we're going to look to make some modifications is actually back in the code. So I'm going to open that up again and bring that window over here. And oops, I've accidentally added a number 1 here, so I'm going to get rid of that. So we've got our code, and basically what happens within this code is that we are manipulating essentially the way that we are sampling in the textures from the inputs, and during that process are also adding a hue shifting effect in this section here. So we first are doing our texture sampling, we're getting our feedback, our random values, we're setting up our color output, and likewise that is also pulling from the feedback input as well. And then we're doing this within this section here, converting to HSV values. Then we're adding 0.05 to those values, and then we're converting back to regular RGB color and using a fract function to leave us with just the fractional component. What we can do is to add in a uniform to be able to control the amount by which we are shifting each one of these channels. And remember that these are corresponding, because we're going to be in this HSV mode, to hue saturation value. So what we can do is actually add back the uniform it was actually a constant in the original code, but I'm going to add in a uniform float called AMT for amount. And we can then replace all of these 0.05s with AMT. Once we do that, hit save, head back to TouchDesigner. We'll have our little flag because, of course, we don't have AMT defined yet as a vector. I'm going to add another vector here. We'll call this AMT. And remember that this value initially was set at 0.005. So if I set it back to that value, we should return to the kind of default state. But I could also reduce this value maybe to 0.02. And you can see that by adding less of that rotation, we end up with a different result. Things end up looking a little less choppy, a little less noisy, and maybe a little less interesting because they don't tend to move as much. But you can work with this value and see what kind of results you end up liking or not. Another thing I want to mention is that while we're doing any of these manipulations, if you are photosensitive to flashing effects, definitely proceed with caution, because playing with this AMT value or the next effect that we're looking at will, in some situations, cause flashing effects. So we've got our amount set up. Let's take a look at another possibility. What I'm going to do in this case is to composite the original null input signal with the feedback signal. And I'm going to use the composite top for this. And what I will do is connect the input to the second, or that multi-input connector there. And then I will set the operation here to dimmest. Once we set it to dimmest, you'll see that we end up with this very different effect than normal. We still get this kind of trailing effect, but we are now keeping a portion of that original image in the mix as well. Now with this particular texture, because we don't have, any movement in it, everything looks kind of static except for a couple of these areas here where we see movement. But if you were to add something like displacement and manipulate this texture prior to it entering the feedback loop, you can end up with these interesting sort of trailing effects and a little bit more motion to the final outcome. You're also, of course, welcome to play around with adding additional operators into the feedback loop. There are countless ways to manipulate the feedback textures, as we know from many different TouchDesigner tutorials over the years. But I thought this would be at least enough to kind of get you started with playing around with this effect. So with that said, I hope you have enjoyed putting this one together. Definitely check out Adam Ferriss's work on his website and elsewhere on the internet. And as always, looking forward to seeing you in the next video. Thanks so much for watching.
Hey folks, thanks for watching. If you like our YouTube content, I highly recommend you check out the Interactive and Immersive HQ Pro. The HQ Pro is the only comprehensive educational resource and community for immersive design, TouchDesigner, and creative tech pros. In the HQ Pro trainings, we cover almost any topic you can think of, and we go way more in depth than we do in our YouTube tutorials. We have a private group where Matthew Reagan, myself, and our other industry veteran and pioneer teachers answer your questions every single day. If that sounds cool, click the link in the description to learn more. And if you enjoyed this video, hit that like button and don't forget to subscribe for more free TouchDesigner and immersive content.